Hello everyone, I'm Melinda Harta and with my partner Fance Satria Nusantara. Today we are pleased to present our paper with title Detecting Homograph Phishing Attack Using Catboost and Feature-Based URL Analysis, submitted to CENIM 2026. Here is our plan for today. First, we look at the problem and the resource gap. Then our proposed framework, dataset, and experiment design. Finally, we share our results and conclusion. Phishing remains a major cybersecurity threat. In the first quarter of 2026, more than 971,000 phishing incidents were reported, an increase of 13.0%. Our research focuses on one specific type called a homograph attack. In this attack, a character in a domain name is replaced with another character from a different alphabet that look almost identical. As shown here, replacing the letter E in google.com with a Cyrillic character creates a domain that appears legitimate but redirects users to a malicious website. Why is this problem still difficult? Deep learning models are accurate but require high computing power. Hash-based methods are fast but can only detect attacks they already know. XGBoost also needs additional feature encoding. This figure shows our purpose framework. We first collect legitimate URL from Trenko and phishing URL from Pistang, then clean the data, generate homograph samples, and balance the dataset. Next, we extract structural and lexical features and evaluate 3 experimental scenarios. Finally, we train and tune for machine learning models using randomized search CV with 5-fold cross-validation, then evaluate them using classification metrics, confusion metric, and feature importance. We collected 1 million legitimate URL from Trenko and about 58,000 phishing URL from Pistang. Since real homograph samples are limited, we generate them by replacing one or two Latin characters in a legitimate URL with visually similar Cyrillic character. After balancing, the dataset contains 75,000 URL evenly distributed across 3 classes.
Okay, about feature engineering, we extracted two groups of features. The first group is structural features, which look at the URL structure, such as its length, the number of digits, the number of dots, and the domain length. The second group is lexical features, which analyze the characters and patterns in the URL. These include channel entropy, which measure how the random URL looks, then honeycomb detection, which detects special character in domains, and script mixing, which detects different alphabets used together. As we'll see later, script mixing is the most important features. For our experiment, we split the data into 80% for training and 20% for testing. We tested 3 scenarios. Scenario 1 uses only basic structural features like URL length, number of dots, digits, and domain length. Scenario 2 adds a hash vector like SHA256 on structural features, and scenario 3 for full setup combines structural and lexical features together. We compared 4 models: logistic regression, random forest, XGBoost, and CatBoost across all 3 scenarios. Each model was tuned using randomizer CV with 5 cross-validation and 10 iteration to make sure the robustness of the models. Here are the results. In the first 2 scenarios, all models achieved only around 60% accuracy. And then once we added the lexical features in scenario 3, every model exceeded 91% accuracy, showing that these features made the biggest difference. CatBoost achieved the best performance with 93.34% accuracy and 94.04% precision. Overall, this suggests that feature engineering has a greater impact than the choice of machine learning algorithm. Let's look at the confusion metrics. CatBoost correctly detected 4,964 out of 5,000 homograph URLs, while only 3 legitimate URLs were incorrectly classified as homograph. Most errors comes from conventional phishing URL because they usually do not contain cross-script character. In conclusion, combining structural and lexical features enables effective homograph phishing detections. CatBoost achieved 93.37% accuracy and 94.04% precision, with very few false positives. We also found that the feature engineering is more important than the choice of classifier. One limitation is that our model is less effective for conventional phishing attacks that do not use character substitutions. In future works, we plan to include additional URL features and integrate real-time threat intelligence to improve detection. Thank you for your attention. We hope this presentation has provided valuable insight into our proposed homograph detection system. The source code and dataset can be accessed through the GitHub link at the bottom of this slide. Thank you and see you.